Water. Here we'll discuss about water as universal solvent, qualitative effect of temperature on solubility, hydrated substances, anhydrous substances, properties such as efflorescence, deliquescence, hygroscopy, drying and dehydrating agents. Water as universal solvent dissolves more substances than any other liquid. Water is an excellent solvent. It is polar covalent compound. Due to polarity of each molecule, it can dissolve many substances. It is extremely difficult to get pure water in nature. Solution. Solution is a mixture of solid and water. Solid is the solute, while water is the solvent. Depending upon the amount of solute present, the solution may be saturated or unsaturated. When solute is added, if the solute dissolves, the solution is unsaturated. If the solute does not dissolve, it is saturated. Saturated solution. Solution which can dissolve any more of solute at a particular temperature. With increase of temperature, saturated solution can dissolve more solute. Solubility increases with increase of temperature. With increase of temperature, same amount solvent can dissolve more amount solute. Solubility. Solubility is the amount of solute that can saturate 100 gram water at a particular temperature. Solubility curve. Solubility curve is the solubility of gram of salt in 100 gram water versus temperature in degrees Celsius over the x-axis. Here, solubility of certain salts can be noticed. Example, solubility of KNO3. At 30 degrees Celsius, the solubility of KNO3 is 46 gram, while at 50 degrees Celsius, it's 90 gram. Thus, we can deduce from the above that the solubility of KNO3 increases rapidly with rise in temperature. Solubility of NaCl. At 30 degrees Celsius, it's 35 gram, and at 50 degrees Celsius, it's 37 gram. Here we can deduce that it remains unchanged with rise in temperature. Solubility of calcium sulfate decreases with rise of temperature. Hydrated substances. Substance with water of crystallization. Substance that has fixed number of water molecules in loose chemical combination are referred as hydrated substance. The fixed number of water molecules in loose chemical combination is called water of crystallization. Hydrated copper sulfate or copper sulfate pentahydrate has 5 water molecules as water of crystallization and is generally blue in color. Anhydrous copper sulfate has no water molecules and is white in color. Dehydration. Removal of water molecules which are chemically combined is referred as dehydration. Dehydration can be done either by heating or adding dehydrating agents such as concentrated H2SO4. Effect of dehydration. With the removal of salt of crystallization, the crystalline structure is lost. The salt turns amorphous or powdery. The color is lost. The salt turns white. Examples of hydrated salts: green vitriol, ferrous sulfate heptahydrate FeSO4.7H2O, Epsom salt, magnesium sulfate heptahydrate MgSO4.7H2O, Glauber salt, sodium sulfate decahydrate Na2SO4.10H2O, washing soda crystals, sodium carbonate decahydrate Na2CO3.10H2O. The above two, Glauber salt and washing soda crystals, are efflorescent substances. Efflorescent substances are the substances that lose water of crystallization when exposed to air. Efflorescence. Certain hydrated salts, when exposed to air, loses water of crystallization, partly or completely. This phenomenon is known as efflorescence. Glauber's salt loses water of crystallization completely when exposed to air. Na2SO4.10H2O on exposed to air gives Na2SO4 plus 10H2O. Washing soda crystals lose water of crystallization partly when exposed to air. Na2CO3.10H2O on being exposed to air gives Na2CO3.H2O plus 9H2O. Deliquescence. Substance absorbs moisture from the atmosphere, dissolves in the absorbed moisture, turns into solution. Deliquescent substance. Example, ferric chloride. Ferric chloride when exposed to air turns into yellow solution. Calcium chloride. Calcium chloride turns into colorless solution when exposed to air. Highly deliquescent substance. Table salt. Table salt turns watery during rainy season. NaCl is not deliquescent. CaCl2, MgCl2 present as impurities in table salt are deliquescents. Absorb water molecules and dissolve in the water molecules. Hygroscopy. Hygroscopy is the phenomenon of absorbing water molecules when exposed to air. Hygroscopic substances, unlike deliquescent substances, does not dissolve in the absorbed water molecules. Hygroscopic substances. Example, phosphorus pentoxide, calcium oxide, concentrated sulfuric acid, etc. Hygroscopic substances. Drying agent. Absorbs water molecules only from wet substances where the water molecules are not chemically combined with the substance. Dehydrating agent. Absorbs the chemically combined water molecules from compounds. Dehydration. Sugar turns black with concentrated H2SO4. C12H22O11 on passing through concentrated H2SO4 gives 12 carbon plus 11 water molecules. Dehydration. Copper sulfate crystals turn white with concentrated H2SO4. CuSO4.5H2O gives CuSO4 plus 5H2 on the presence of concentrated H2SO4. Difference between efflorescent, deliquescent and hygroscopy. Efflorescent loses water of crystallization when exposed to air. Deliquescent absorbs water molecules when exposed to air, dissolves in the absorbed water molecules and turns into solution. Hygroscopic absorb water molecules when exposed to air. Efflorescent turn powdery when exposed to air. Deliquescent turns into solution when exposed to air. Hygroscopic doesn't form solution or turns powdery when exposed to air. Efflorescent mass decreases when exposed to air. Deliquescent mass increases when exposed to air. Hygroscopic mass increases when exposed to air. Hard and soft water. Hard water and soft water. Hard water produces no lather with soap, while soft water produces lather with soap. Causes of hardness. Presence of dissolved calcium and magnesium salts in water are the reasons of hardness of water. Hardness can be categorized into two further groups: temporary hardness and permanent hardness. Temporary hardness are caused by dissolved calcium bicarbonate CaHCO3 whole twice and magnesium bicarbonate MgHCO3 whole twice. Temporary hardness can be removed by boiling. Permanent hardness caused by dissolved calcium chloride CaCl2, magnesium chloride MgCl2, calcium sulfate CaSO4 or magnesium sulfate MgSO4. Permanent hardness cannot be removed by boiling. Removal of temporary hardness by boiling. Soluble calcium bicarbonate or magnesium bicarbonate changes into insoluble calcium carbonate or magnesium carbonate. Insoluble calcium carbonate or magnesium carbonate is then removed by filtration. Their reactions are as follows. CaHCO3 whole twice gives CaCO3 plus CO2 plus H2O. MgHCO3 whole twice gives MgCO3 plus CO2 plus H2O. Removal of permanent hardness by adding washing soda, that is Na2CO3. Insoluble CaCO3 and MgCO3 are precipitated. This insoluble CaCO3 and MgCO3 are removed by filtration. Chemical equations involved here are CaCl2 plus Na2CO3 gives CaCO3 which precipitates down and 2NaCl. MgCl2 plus Na2CO3 gives MgCO3 plus 2NaCl. CaSO4 plus Na2CO3 gives CaCO3 plus Na2SO4. MgSO4 plus Na2CO3 gives MgCO3 plus Na2SO4. Hard water, advantages and disadvantages. Hard water advantages. Minerals present are good for health. Disadvantages. Not suitable for washing as soap doesn't produce lather. Not suitable for boilers. Hard crust is formed.